All right, I'm going to try to show you how to calculate the settings for the oscilloscope. And I have this picture of an oscilloscope with a sine wave on it. And you'll notice that the sine wave goes from top to top across 1, 2, 3, 4, 5 divisions. Just to review, the oscilloscope in HSH 201 is a Rigol, and the Rigols have 14 divisions across horizontally in the time axis, and they have 8 divisions vertically in the voltage axis for what we're displaying. And when we talk about the amplitude of a wave, we're talking about the height of the wave from the middle. So when you look at this wave, you can see that it covers or uses 3 divisions. So down here in the bottom it says 1 volt per division, and so this has an amplitude of 3 waves. Up here a little bit to the top, you can see 1 millisecond per division, and so since it's 1, 2, 3, 4, 5 blocks or divisions wide, this is a 5 millisecond wave, and that's going to be 200 kilohertz, or 200 hertz. So that's a review of what's on the screen. Let's talk about how we would calculate the settings. There are some knobs over here on the side that aren't shown in the photograph, and you have to turn the knobs in order to change the value of the divisions. So I've got a little CAD sheet here, and I'm going to say that we have a sine wave that is 600 millivolts in amplitude. And I've defined right here that we have 4 horizontal divisions. Let's go back and count those again. From this middle line, we have 1, 2, 3, 4 horizontal divisions. I have an amplitude of 160 millivolts. So in order to get the volts per division, I divide the amplitude by the number of horizontal divisions, and I get 150 millivolts. Now, the oscilloscope doesn't have a setting for 150 millivolts. All of its settings start with 1, 2, or 5. You can have 1 millivolt, 2 millivolts, 5 millivolts. If you turn it one larger, you're going to be at 10 millivolts. Then you can go to 20 or 50. And our calculation here says, hey, we need 150 millivolts. Well, you can't display a smaller number than that. If you displayed a smaller number, you wouldn't show the whole wave. So you have to find the next higher setting. So that's the question here. What is the next high setting above 150? We're showing a value that's in the hundreds. So we're going to have to either have 100, 200, or 500. The next highest setting is 200. And so we have a setting of 200 millivolts. And we'll turn the knob on the oscilloscope until we see 200 millivolts displayed right down here. So instead of 1 volt, you'll actually be able to see 200 millivolts. And the same thing will be done then for the horizontal. Let's say that, well, first of all, let's note that we have 14 vertical divisions. And let's say that we have a frequency of 100 kilohertz. So with a frequency of 100 kilohertz, the wave's going to repeat 100,000 times per second. But we're interested in the length or time it takes for a wave to complete. So that's the period of the wave. In order to get that, we take 1 over the frequency, and 1 over 100,000 is 10 microseconds. So it takes 10 microseconds to complete one wave. Now, on the oscilloscope, we'd like to show 2 complete waves. So you'll notice here that I have multiplied the period, which we calculated up here, times 2 to get the width of 2 waves. And that's going to give me, obviously, 20 microseconds. Now, I need to know the setting per division, and I divide the width of the 2 waves by the number of vertical divisions. Remember, we have 14 vertical divisions. So I take the width of the 2 waves, divide it by 14, and I end up with this weird number. Now, I've already got the answer down here, but let's review once again. The settings are 1, 2, or 5 in whatever unit we want to use. And in this case, we're going to use microseconds. So we would have to, if it was already higher than microseconds, we'd have to turn the setting down until we got in the microsecond range. And 1.4 is greater than 1, but less than 2. We want to basically take kind of a strange ceiling function and go to the next higher setting from our calculated value. And the next higher setting is 2, and so we set the oscilloscope at 2 microseconds. You turn the knob until you see 2 microseconds up here in this upper corner, and you will be set. So this short 5-minute video hopefully walks you through how to calculate that. Thanks for watching. Hope Hope it helps you in class.